Hey everyone, so welcome back to my channel again, Intelligent Learners. In this video, we are going to discuss the power property of logarithm, which is again the byproduct of the power property of exponent, right? And you know that exponent and the logarithm, they have the inverse relationship. So let's start with the video, everyone. Please understand it very carefully, right? So thank you. Let's start. Power property of logarithm. Whatever the properties that we are finding out of the logarithm, they are coming from the exponent properties only, right? So which property of exponent we will use, everyone? We will use the power of the power property of the exponent. Let's say we have the power 2 raised to the power 3 as an exponent. So the value of 2 raised to the power 3 is 2 times 2 times 2, which is 8. If I will take another power of 2 raised to the power 3, let's say I have taken again the power of 2 with 2 raised to the power 3. So please remember, inside power and outside power got multiplied. Okay, which gives me 2 raised to the power 6, the value of which is 2 times 2 times 2 times 2 times 2 times 2, which is 64, correct? And if I will see that the square, if I will take, because I'm taking the left hand side square, so if I will take the square of right hand side, which is 8 power 2, which is 64 only. So value is same. So that is means the power of power. Now what I will do, because I'm proving a property, general property, so I will take a general exponent. So let's take, I will take b raised to the power x. I have taken as any value, let's take m. Okay, I have taken m. Now what I will to do, everyone, I will take the double power. So I have to take double power. So let's say I'm multiplying with power k both sides. Whatever I'm doing in the right hand side, same thing I will do in the left hand side. Okay, so I have taken the double power. Now when I took the double power, what I will do, I will open the bracket. So it will become xk, that is equals to m raised to the power k. Now if I will convert this exponent form in the logarithm form, we know that if I have to convert this exponent form in the logarithm form, so how it will convert? The base is 2, base will come as a base, value will come here, and the exponent goes there. This is the conversion of the exponent form into logarithm. So same thing, this is the base for me. Let me show you. This is the base for me. This is the value and this is the power. So log base b value, which is m raised to the power k, that is equals to xk. This is not x raised to the power k because powers are multiplied. When inside bracket, outside bracket you have power, it got multiplied. So this is this. Now everyone, what I will do, log base b m raised to the power k, that is equals to, what is the value of x? If I will see this exponent which I have taken in the starting, if I directly convert this into the log form, how I will convert? Log base b, value will come here and this will be x. So the value of x is what? It is log base b m multiplied with k. So this is the proof. Okay, everyone, it's very easy. So now please remember, what is the property, everyone? The property is whenever you have log base b or any base and you have a value which is m raised to the power k, so that power will come forward always. Okay, so I, because it's a coefficient for the log, so you will take k here also, or you will write k dot log base b m. Okay, this is also by the way you can write. So this that, for example, if I will say, I will give you an example also to make you understand. If I have a value log base 2 raised to the power 3. Okay, I converted 8 into 2 to the power 3, let's say. So this power will come forward. Okay, this is the property of log 2 raised to the power 2, right? So